Thanks for click this video. Now I will talk about the difference between deep learning and usual machine learning. If anyone interested this type topic, please subscribe our channel. Machine learning, ML, is the study of computer algorithms that can improve automatically through experience and by the use of data. It is seen as a part of artificial intelligence. Machine learning algorithms build a model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to do so. Machine learning algorithms are used in a wide variety of applications, such as in medicine, email filtering, speech recognition, and computer vision, where it is difficult or unfeasible to develop conventional algorithms to perform the needed tasks. Deep learning is part of a broader family of machine learning methods based on artificial neural networks with representation learning. Learning can be supervised, semi-supervised, or unsupervised. Deep learning is a class of machine learning algorithms that use multiple layers to progressively extract higher-level features from the raw input. For example, in image processing, lower layers may identify edges, while higher layers may identify the concepts relevant to a human, such as digits or letters or faces. A subset of machine learning is closely related to computational statistics, which focuses on making predictions using computers, but not all machine learning is statistical learning. The study of mathematical optimization delivers methods, theory, and application domains to the field of machine learning. Most modern deep learning models are based on artificial neural networks, specifically convolutional neural networks, CNNs, although they can also include propositional formulas or latent variables organized layer-wise in deep generative models, such as the nodes in deep belief networks and deep Boltzmann machines. Machine learning also has intimate ties to optimization. Many learning problems are formulated as minimization of some loss function on a training set of examples. Loss functions express the discrepancy between the predictions of the model being trained and the actual problem instances. For example, in classification, one wants to assign a label to instances, and models are trained to correctly predict the pre-assigned labels of a set of examples. Deep learning is closely related to a class of theories of brain development, specifically neocortical development, proposed by cognitive neuroscientists in the early 1990s. These developmental theories were instantiated in computational models, making them predecessors of deep learning systems. These developmental models share the property that various proposed learning dynamics in the brain, a wave of nerve growth factor, support the self-organization somewhat analogous to the neural networks utilized in deep learning models. Self-learning as a machine learning paradigm was introduced in 1982 along with a neural network capable of self-learning named Crossbar Adaptive Array, CA. It is a learning with no external rewards and no external teacher advice. The CA self-learning algorithm computes, in a crossbar fashion, both decisions about actions and emotions, feelings about consequence situations. The system is driven by the interaction between cognition and emotion. The self-learning algorithm updates a memory matrix. Realistically, deep learning is only part of the larger challenge of building intelligent machines. Such techniques lack ways of representing causal relationships, have no obvious ways of performing logical inferences, and they are also still a long way from integrating abstract knowledge, such as information about what objects are, what they are for, and how they are typically used. The most powerful AI systems, like Watson, use techniques like deep learning as just one element in a very complicated ensemble of techniques, ranging from the statistical technique of Bayesian inference to deductive reasoning.